So what can we do? Right? Like, great, climate change is here, that sucks. But what can we actually do? What can we do to make change? Now, I'll be upfront and I'll be honest with you. You and I, although we are contributing to it, we're really not the biggest players. Well, one, if you think about countries around the world, but industries are a really big player too. And some things we really can't help. It's up to our government. But that doesn't mean that what you're doing doesn't make a difference. I mean, literally every little bit helps, especially because of how big this issue is. There's 7.5 billion people in the world. If everyone had the mindset of, oh, this little bit that I'm doing doesn't matter, then yeah, no duh, that climate change is happening because we all think that we can't make a difference, but we can. So this little unit, I have this think green here. The biggest thing too is like, if you don't care about the environment, hopefully, because you've gone through my entire class, you care like a little bit more. But let's say you don't. Pretty much all these strategies that I'm going to talk about that can help you reduce your greenhouse gas emissions are ways to also save you money. So if you don't care about the green of the earth, maybe you care about the green of your pocketbook. And I realize I just said the word pocketbook, which none of you probably have, but you get my point. So hopefully you'll take something away from this. So let's talk about transportation. You have talked about transportation before. You know that different forms of transportation are going to be better, but I'm going to help explain why and kind of talk about some of the math behind it. So let's imagine you're at home and you're with a brother or your sister, and you've got a car and you drive from point A to point B. Now let's just say, oh, well, that's a little off. Let's just say for argument's sake that your drive from home to school, let's say it is a 10-mile drive. So 10 miles to go from A to B, in this case, home to school. Now let's say your car gets 10 miles per gallon, which means for every gallon of gas that you use, you should get about 10 miles out of that. So if we take a look at this, if it takes you 10 miles to get to school and your car can get 10 miles for every gallon, my question is how many gallons of gas does that take? Hopefully this should be pretty easy to you and you figured out like, oh, that's 1 gallon of gas. Essentially what I did is I took that 10 miles and I divided it by the 10 miles per gallon. Okay, so that's how many gallons I get. But the thing is like, when you think of gallons of gasoline burned, that doesn't really put it into greenhouse gas emissions like format. So this really important number that you should know, and I would give it to you on the test if you were to see it, is that for every gallon of gasoline that's burned, about 20 pounds of carbon dioxide is released into the environment. Now 20 pounds of a gas doesn't quite make sense. So imagine, those blue exercise balls? That's about 1 pound of a gas. So 20 pounds of carbon dioxide is about 20 exercise balls filled of carbon dioxide. Right, that kind of puts it into perspective, and that is a lot of carbon dioxide. So when you're burning your gasoline, it's not it's a little trickle of carbon dioxide. It's actually quite a bit of carbon dioxide that's released. So this number, this 20 pounds of carbon dioxide per gallon of gasoline, we're going to use that as we analyze different ways of tackling that. So let's get another example. So one thing that you could do that a lot of people say is, oh, we'll take public transportation. So let's say I take public transportation. Now typically bigger vehicles get not so great miles per the gallon. So let's take that same scenario. You're going to go 10 miles from A to B. This bus is not super efficient, so it gets about 10 miles to the gallon, which, just like your car, that's going to be 1 gallon of gasoline. And we know 1 gallon of gasoline equals 20 pounds of CO2. But here's the issue. Or not really the issue, but here's the thing. You're like, well, that's the same amount. Why is that better? Because typically it's not just you on the bus. Imagine there are 9 other people on the bus. So on your bus there is a total of 10 people. Well, those 10 people are sharing that 20 pounds of carbon dioxide. So if we look at a per person basis, if we've got 20 pounds of carbon dioxide, but we're dividing that by 10 people, per person, that's only 2 pounds. It's not 20 pounds a person, it's 2 pounds a person. So although the bus itself may not be super efficient, the people on it is what makes it efficient. The other thing too is that bus is always running. That bus is going to have to use that carbon dioxide and have to use that gasoline no matter what. You, the person driving your vehicle, does not have to use your vehicle no matter what. So that's the other thing too, is taking advantage of the fact that this vehicle is already going to be running. Now something else you could do, I'll actually go ahead and put this on a new screen. Sorry that I've been kind of putting it all on one. What if we took a hybrid? So taking a vehicle and getting a more fuel efficient vehicle. So let's say you are in the market for a new car and you're like, yeah, I'll just go buy a hybrid. So let's say a hybrid gets 40 miles to the gallon, and we're going to say you've got the same commute, you need to go 10 miles. So my question is, how many gallons? And once you figure out how many gallons, how many pounds of CO2? Now, for those of you who have taken algebra or kind of remember it recently, I'm going to set up this problem as if I'm setting up an algebra problem. You could set this up however you wanted to. So I'm going to take my gas mileage. I get 40 miles for every 1 gallon. Now the thing is I'm traveling 10 miles. Now typically when you set up these grids, you try to put the units diagonal from one another. So in this case, I'm going to put 10 miles down here. And so, oh, hold on real quick. Let me double check this. Oh, I did this backwards. So sorry, I semi did this backwards. The thing that we are searching for, we want to know how many gallons of gasoline. This actually needs to be on top because that's what we're looking for. So let me apologize and kind of cross all this out. So we have 1 gallon of gasoline. 1 gallon of gasoline will get us 40 miles. And because we want units diagonal from each other, we know we're going 10 miles. So what I need to do is I need to do 1 times 10, which equals 10, divided by 40, which equals 1/4. Now the miles cancel each other out, but what's left is 1 gallon, or really 1/4 gallons. So I use 1/4 of a gallon of gas in order to go 40 miles. Now if you're like, oh my God, there's no way I'm going to remember how to set up this kind of formula, don't worry about it. Just think it through. Let's say you messed up like I did. Let's say you did this up here and you're like, oh, well, 40 divided by 10 equals 4 gallons of gas. You're going to tell me that a hybrid vehicle that can go a lot further on a gallon of gas uses more gasoline than a regular vehicle? That doesn't make sense. So if you can't remember, just do one of them, and does your answer make sense? If this is a better fuel efficient car, well then it should be using less gasoline. I can go 4 times the distance, so I can use 1/4 the amount of gas. So in this case, I use 1/4 a gallon of gas. So I'm going to write that as a decimal, so 0.25. We know that 1 gallon of gasoline equals 20 pounds of CO2. So when I multiply that, I get 5 pounds of CO2. I went the same distance. I'm using a motor vehicle. I'm just using a more fuel efficient motor vehicle. The engine is better and it can actually use the fuel better in order to make it go further. So that's another alternative. Finally, I mean, you could just walk or bike. Carbon dioxide does increase though because you're breathing more, right? But it's negligible compared to actually burning fossil fuels. So just changing your transportation habits. Even carpooling with someone. Instead of both of you driving and both of you releasing emissions, one of you drives. And by one of you driving, you're saving quite a bit. So you can kind of do this calculation really for anything, any type of transportation. Really, you just need to know how efficient is it. Does it get 10 miles to the gallon, 20, 50? That's really all that you need to figure out, okay, how much carbon dioxide am I actually releasing? So that's one thing you can do, is changing your transportation habits. Another thing you can do is looking at our electricity. Remember that electricity and energy is the #1 way that we are using carbon dioxide, or how we're releasing carbon dioxide. So there's actually two different topics, or two different categories of way we can reduce our emissions when it comes to electricity. One is conservation. So when we use the word conservation, when we're talking about energy, this means not using it. So we don't use that electricity in the first place. The other concept is efficiency. Efficiency is you use it, but use less for the same function. And I'll kind of explain what both of these mean with examples. So for example, conservation. That would be just not using the electricity. Instead of having the lights on, turn them off. If you're leaving a room, turn the lights off. If you are in a room but you've got natural sunlight on, open up the curtains, turn the lamps off. This doesn't have to be just lights, it could be your TV. If your TV's on but no one's watching it, turn it off. If you left your Xbox on, turn it off. So just turning things off when you're not using them. That means you're not using the electricity in the first place, which means coal is not being burned for you. Another thing you can do is unplugging your stuff. So appliances draw energy even if they're not actually on. Your TV is still drawing electricity. Your microwave still drawing electricity. Lamps still drawing electricity. Now, depending on whatever electronic it is will affect how much electricity is being drawn, but it's still drawing electricity and you're not even using it. So what you can do is you can unplug things, or you can plug things into a surge protector and just turn the surge protector on and off. Now, are you going to unplug your microwave every time you use it? Probably not. Maybe you like the clock on it. Are you going to unplug your lamp instead of just turning it off? Probably not. But let's say you're going out of town for a week. Hell yeah, unplug that microwave, unplug that toaster, unplug things. Or also appliances that you don't use every day. If you've got a blender sitting plugged in and you use it once a month, just unplug it, put it away. So just unplug things. It's not a lot of energy, I'll admit, but it makes a difference. Everything makes a difference. So that's one thing, side of things. Conservation, you're not pulling that electricity anyway. However, efficiency is you are doing something, you are using something, but it's a more efficient model. It can do that same function as a conventional or less efficient product, but it does so by using less energy. When we think of fuel-efficient vehicles, these are vehicles that are using gasoline to get from A to B, but they're using less gasoline to do that. So for example, you might have seen this Energy Star logo on different appliances, on different electronics. Energy Star is an actual government government certification that is essentially identifying, hey, this refrigerator is more energy efficient. Typically, it just means it needs to use less energy than a majority of the market. So if you see this sticker, what it's telling you is that, hey, this refrigerator is still going to keep your food cold, but it's going to use less electricity to do so. You're still using electricity. This is why it's not conservation. Conservation would be unplugging your fridge. But efficiency is you still have the fridge, you're just not using as much. Another example of energy efficiency is thinking about light bulbs. So you've probably seen, so these are LED lights. You've probably heard of LED lights before, but you've probably seen, oh, I know, this is a very bad picture. The curly light bulbs. Those are energy efficient light bulbs as well. And what these light bulbs do is they still light up the room. I still have light here, but they're using less energy than a typical light bulb. This metric is actually showing you. So this is saying this light bulb uses 4.4 watts. Watts is a unit of electricity. But despite it only using 4.4 watts, it actually gives off about as much light as a typical 20-watt bulb. So it's using about 1/4 to 1/5 the amount of electricity that a regular light bulb uses. If you are in a big house that's got a whole bunch of lamps in it, this literally adds up and can make a big difference in your bills by just changing the type of light bulbs you're using. So again, efficiency, you're still using electricity. You're just not using as much as compared to other products.